Hello everyone, this is a short numerical video series actually on discrete time signal processing. Now the first chapter that we are looking at is transform analysis of linear time invariant systems, also known as frequency response chapter sometimes. Now in this chapter what we are asked is to first find h of z, okay, then we have to sketch the frequency response and then identify the type of filter. Now as you all know, there are three major types of filter. One is high pass, another is low pass, and third one is all pass. High pass, it will pass the higher frequencies and block the lower frequencies. Low pass, it will pass the lower frequencies and block the higher frequencies, and all pass will pass all of them. Okay, so let's look at the question. H of n equals to 1 comma minus half. This is given to us. So what we can do, first step to find is h of z. Okay, you have to find h of z. Now since h of n is given and I have to find h of z, I know that h of z is equal to summation h of n into z raised to minus n. Now this n actually goes from minus infinity to plus infinity, but here my n will go from 0 to infinite. Okay, so let's write it down. My h of z will be equal to h of n for the first one, which is 1 into z raised to minus, I told you it is from 0 to infinity here, so it will go to z raised to minus 0. Z raised to minus 0 is nothing but z raised to 0, and z raised to 0 is 1. So my first term will be 1 into 1. Okay, now my second term, h of n will be h of 2. H of 2 is nothing but h of 1. Now this was 0th position, this is my first position, so this is minus 0.5 into z raised to minus 1. So my h of z is typically 1 minus 0.5 z inverse. Further, I can write this as 1 minus 0.5 upon z, right? Further, what I can do is z minus 0.5 by z. This will be my final equation. Now in this type of question, if I evaluate denominator equals to 0, okay, if I put denominator, which in this case is z, equal to 0, this gives me my pole. And if I put numerator equal to 0, which in this case is z minus 0.5 equal to 0, the answer that I will get from here will be a 0. As you all know, there are two things, poles and zeros. So here my pole is equal to 0, z equals to 0, and my 0 will be equal to z equal to 0.5. Okay, now what I have to do, as asked in the question, I have to find the frequency response. I have to sketch the frequency response. So what I will do is, I will put z equal to e raised to j omega. Okay, please remember this. For any question, if you are asked to find the frequency response, put z equal to e raised to j omega. So what was my h of z? My h of z was 1 minus 0.5 z inverse, right? Now in place of z inverse, I will put e raised to j omega, e raised to minus j omega, right? And you all know that e raised to I theta is nothing but cos theta plus I sin theta, and e raised to minus I theta equal to cos theta minus I sin theta. Okay, using the same analogy, what I will write here is 1 minus 0.5 e raised to minus j omega will become cos omega minus j sin omega, and now I will multiply 0.5 with them. So 1 minus 0.5 cos omega plus 0.5 j 0.5 sin omega. This will be my final expression. Now this term and this term, these both terms, these are real terms. Why? Because they do not have any j factor with it, and this is my imaginary part. So I will write the real and part together. So 1 minus 0.5 cos omega plus imaginary 0.5 sin omega. Okay, I can write this down here. Now my magnitude response is nothing but magnitude of h of omega. And what is this h of omega? Whatever we found out just now, that is my h of omega. Why? Because we substituted z equals to e raised to j omega. Now modulus of h of omega is my magnitude, and that is equal to under root of real part square. Okay, under root of real square plus imaginary square, which in this case will be equal to 1 minus 0.5 cos omega square plus 0.5 sin omega square. Now I can expand this a minus b the whole square. Okay, after expanding it and solving it, finally you will have something like this: 1 minus cos omega plus 0.5 square, which is nothing but 1.25 minus cos omega. Okay, now what about, now this is my magnitude. This answer is my magnitude. What about my phase? Phase is nothing but my angle. Okay, so what about my phase? My phase is equal to tan inverse of imaginary part upon real part. What is my imaginary part? It was 0.5 sin omega upon my real part was 1 minus 0.5 cos omega. Now please remember or notice one thing. When I wrote magnitude equals to real square plus imaginary square, I wrote the real part, and in imaginary I did not include j. Okay, please do not include j, because j just signifies that it is the imaginary part. Okay, and similarly in phase response I wrote tan inverse of imaginary upon real, but I did not write j 0.5 sin omega. Please exclude j. J just denotes the imaginary part. Okay, it will just give you the name of the imaginary part. Please do not write imaginary and then name. Just write the magnitude with, which was with j, and the real part. Okay, now what you have to do? Put the values of omega. Put 0, pi by 2, minus pi by 2, then pi, then 3 pi by 2, minus 3 pi by 2, and finally 2 pi and 2 pi. Put these values of omega in two things. First in the magnitude and then in the phase. Then sketch them. How you have to sketch them? Basically, you have to draw this. Okay. On your x-axis will come omega. Okay, which is nothing but, here it will be 0, then here it will be pi by 2. Pi by 2 is nothing but 3.14 divided by 2, which is 1.57, and here you will have minus 1.57. Then pi is nothing but 3.14, here it will be minus 3.14, and so on. Now whatever values you get after this, plot them on y-axis. Okay, values of omega on x-axis, the values that you get by putting these terms in the magnitude. I am plotting first of magnitude. Okay, in this, plot them on y-axis and then draw the curve. Suppose this is the curve that I am getting. Now you will notice that for lower frequency I am getting some value, and when frequency increases my graph decreases again, and for the middlemost frequency I am having the highest value. Okay, if this is the case that you get, okay, on solving, if suppose for lower frequency you have low value, for higher frequency you have low value, and for middle frequency you will have high value, then it is high pass filter. If suppose it happens that for lower frequency you get high value, for middle frequency you get low value, and for higher frequency you get again high value, then it is low pass filter. And if for all the frequencies you get a constant value, then it is all pass filter. Okay, now this was my magnitude. Now comes plotting of phase. For phase, again x-axis will denote your omega, and whatever value you get after putting omega in this equation, okay, after putting omega in this equation, whatever value you get, plot them on y-axis. After plotting them on y-axis, just draw the graph. Now phase in this, like if I say in general, then phase in this chapter does not denote anything, because we using this magnitude graph we would have already found out whether the filter is high pass, low pass or all pass. So you just have to plot the phase and leave it as it is. Okay, one more important thing to note is the values of omega when you insert them in calculator. Okay, when you insert them here, it should be in radians. Please make sure that it is in radians. Okay, so with this we end the first question, like A part of the first question. Now let's come to the B part. Look at the B part here. Okay, what do you observe? I am given h of z beforehand. That means I do not have to take the z inverse. I just have to start from here. What I will do is I will write the z inverse as 1 by z minus a upon 1 minus a by z. Now just equalize the denominator by cross multiplication. You will have 1 minus az upon z minus a upon z. Z will get cancelled. You will have 1 minus az upon z minus a. Now you all know when numerator is equal to 0, you will get the zeros, and when denominator is equal to 0, you will get the poles. After getting this, what you have to do? Substitute z equal to e raised to j omega. Okay, and after substituting z equals to e raised to j omega, what and in which equation? Now that is the question. Where should you substitute z equals to e raised to j omega? You have to substitute z equal to e raised to j omega in the question. Okay, wherever this z inverse part is present, or you can even substitute it here. The answer, the final answer that you will get will remain same. Okay, now substitute this. After substituting, you all know that my modulus of h omega is nothing but real part square plus imaginary part square. Now you will have a numerator. After solving this equation, you will have a numerator as well as a denominator. So for the numerator also do this, and for denominator also do real part square plus imaginary part square. Then whatever answer that you get, that will be your magnitude. Similarly for phase, what you will do is separate out real part and imaginary part. Okay, separate out real part and imaginary part. Since you will have, like after solving this, you will have in numerator a real part and imaginary part, as well as a real part and imaginary part in the denominator too. So what you will do, first solve for the numerator. That will be tan inverse of imaginary part upon real part. Okay, this is for numerator. then minus of tan inverse of, again, imaginary upon real for denominator. That will give you the phase. Okay, that will give you the phase. And then, as you all know, put the values of omega. 2 pi minus 2 pi minus 3 pi by 2 minus pi by 2, 0 pi by 2, pi, 3 pi by 2 and 2 pi. Put these values, you will get the magnitude as well as the phase. Then plot them, and if the answer comes out to be, let's say, straight line for this question, if you solve this by going through all these steps, you will get the final answer to be a straight line. Okay, which means that this is a all pass filter. And then plot the phase. Okay, with this we end the first question. Now let's move on to the second question. We are given that y of n is equal to 0.9 y of n minus 1 plus b into x of n. Now we have to find b. Okay, we are asked to find b such that magnitude of h of 0 equals to 1, and we also have to find the frequency at which magnitude of h of omega is equal to 1 by root 2. The frequency, that is nothing but my omega, at which magnitude of h of omega equals to 1 by root 2. And then finally we are asked to identify the type of filter. Okay, I won't solve it the whole way, but I'll give you the steps of how to proceed, because after doing this first and second step, the third step of identifying the filter, you have already seen it in the previous question. You have to just put the values of omega, plot it, and then you will understand the type of filter. So first we are given y of n equals to 0.9 y into n minus 1 plus b into x of n. First thing, we are given y of n and we need to find h of z. How to do it? Simple. Take z transform on both the sides. If you take z transform on both sides, you will have z transform of y of n, right, equals to, I can write z transform of 0.9. Now 0.9 is a constant, so it will not come in the transform, it will come out. Y of n minus 1 plus b. B again will be a constant, okay, so it will come out, and I will have z transform of x of n. Okay, I hope you are following me. Now next step, z transform of y of n is nothing but y of z equals to 0.9 z transform of y of n minus 1. Okay, this minus 1 goes to the power, so I will have z inverse of y of z. Okay, equals to, sorry, plus b, this will become nothing but x of z. Okay, now this is y of z, this is y of z. I can take both of them on one side. I will have y of z minus 0.9 z inverse y of z equal to b into x of z, right? I can just take y of z common. I will have 1 minus 0.9 z inverse equals to b x of z. Now my h of z, that was what we intended to find. My h of z is nothing but y of z upon x of z. So here is y of z, here is x of z. What I can do, just bring x of z in the denominator and take this whole expression in the denominator there. So I will have b upon 1 minus 0.9 z inverse. Now this is nothing but my h of z equals to b by 1 minus 0.9 z inverse. Now, what to do further? Simple. Like, it's too simple. We have h of z and we need to find the magnitude. What to do? Put z equal to e raised to j omega. Okay. So I will have h of omega equals to b upon 1 minus 0.9. In place of z inverse, I will have e raised to minus j omega. Right? I can expand it further by cos omega minus j sin omega. I will have 0.9 cos omega minus j sin omega. Next step, yeah, I'll just multiply it. 1 minus 0.9 cos omega plus 0.9 j sin omega. Okay. Take the real part together, imaginary part together. I will have 1 minus 0.9 cos omega as the real part plus j 0.9 sin omega as the imaginary part. Now this was my h of omega. Okay. Next step, yes, you have to find the magnitude, which is very simple. In real, like in the numerator, I just have b. So if I consider this as real or even imaginary, I will have under root of b square, which will give me nothing but at the end b upon under root of real part square, which is 1 minus 0.9 cos omega square plus 0.9 sin omega square. This will give me b upon, and on solving this, I will finally have something like this. 1.81 minus 1.8 cos omega, which is my h of omega, magnitude of h of omega. Now I have to find b such that h of 0 is equal to 1. That was given in the question. Now h of 0 equals to 1, that means omega equal to 0. So I will put here in place of cos omega, I will put cos 0. Cos 0 is nothing but 1. So I will have 1 equal to b upon under root of 1 minus 1.81 minus 1.8 cos 0. Cos 0 is nothing but 1. Okay. Now solve this. When you solve this, put the values in the calculator, you will finally get the value of b. Right? And b will come out to be 0.1. I'll repeat again. We are given, like we are told to find b such that magnitude of h of omega equals to 1. So in place of h of omega, I have written 1, and in place of omega, I have to substitute value 0. So cos omega will be cos of 0, which is nothing but 1. Okay. Solve this, and then you will finally get the value b equal to 0.1. Similarly, now we have the value of b. Okay, and we are told to find the frequency, which is nothing but again omega, at which modulus of h of omega equals to 1 by root 2. At what omega will this be equal to 1 by root 2? Simple again. In place of h of omega, substitute 1 by root 2, and in place of b, substitute 0.1 upon under root of 1.81 minus 1.81 cos omega. Okay, solve this. There is just one variable, that is cos omega. Solve this and you will have the value of omega. Okay, omega on solving this will come out to be 0.1055. And one more thing to note, it will be in radians. Okay. So we are done with this. Finally, what we were asked to find the type of filter. Simple again. You have magnitude. Just substitute the values of omega, which I told you previously, minus 2 pi to 2 pi in this range, and then find it. Now after you do this, let me tell you that you will have something in this sort. Okay, now look at this. At minimum value of omega, you have maximum output, and when omega increases, for high omega you have low value. So low omega, high value, high omega, low value, which means it is low pass filter. Okay, and then you can always sketch the phase. So with this we end our first chapter. I hope you understood the steps, and if not, you can always ask your doubts in the comments. Thank you.